It's great to be here. This is my hometown. It's not often that I get to actually speak in my hometown, so this is great. And welcome to everyone who's watching on the live stream as well. So I am Mike Gualtieri, and I am a principal analyst for Forrester, and I cover advanced analytics, big data, and also AI. And AI has become a very hot topic, and I want to talk to you about that today. Now, most of us, if we're developers, we serve at the pleasure of the business, right? And the business serves at the pleasure of the customer. So it's always good, before we go into some technical subjects, to understand what are the priorities of the business. Now, this particular survey that I'm showing you here, we surveyed data and analytics professionals, right? And you can see that they're completely aligned with the business, because when we do this business survey, the business survey says, okay, customer experience is our number one priority. But you can also see innovation makes an appearance as well. So generally what I do is I look at what people say their priorities are and then try to understand the technology within that context. And at Forrester, our analysis over the last 3 years is that we've entered what we call the age of the customer. And really what this means is that companies are trying to create hyper-personal digital relationships with their connected customers, you know, the digitally connected consumer, blah, 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 right? But the idea is not just to connect these mass customers, but to hyper-personalize it, right? And this is something that used to happen back at the corner store. You walked into the corner store, and they started pulling things off the shelf before you even ordered them. They knew you. So this is what companies are trying to get to at this point. Now, at Forrester, we call this the age of the customers. I kind of net this out, and I just call it friends. That what digitally connected customers want is they want to know you. They want you, the business, to know them as well as they know your friends. That's pretty hard to do, right? Because your friends know lots of things about you. Your friends probably know secrets about you that you wouldn't want to get out, right? But the idea is that if we can understand our customers as we understand friends, that we can create these hyper-personalized experiences. And this is what those experiences have to look like. You have to learn those individual characteristics of customers. You have to learn their behaviors under certain circumstances. You have to predict those needs in real time. So we need a lot of predictive models. And then you have to create a whole new class of applications to adapt to serve those individual customers. Now, how many of you out there think in these terms? This is the way we think developers and application designers have to think. And we don't think many of them do think this way. We think that mostly the design of applications have to do with user experience designers who think about interaction design, the colors, the positioning of things on the screen. But do they really think about how to inject predictive models? We don't think so. Now, the problem with these hyper-personalized experiences is that it's very difficult to scale. You all have a limit on the number of stable social relationships that you can maintain, and that limit is 150. This is the cognitive limit to the number of people with whom you, us, can maintain a stable social relationship. This is called the Dunbar number. Professor did a ton of research on this, even did the research, like Facebook doesn't even extend this anymore. Even if you have thousands of friends, there's still only 150 friends that anyone can have at any one time. And you can see here it's sort of a concentric circle, right? Who are the 5 people you care about the most? They're probably popping into your head right now. And who's the 15 in the circle, right? This is not very scalable, because even if we hired 1,000 people and we multiplied 1,000 times 150, it still doesn't get us to millions of customers. So we have to find a way to understand and scale how we understand our customers. And that is the problem, right? Because many companies, and these are some local companies, Fidelity, Wayfair, TripAdvisor has a big office here, millions of customers. So how do we understand our customers? Clearly it's going to be about predictive models, but it may not be as easy as you think. So let me sort of test your understanding of your customers. This is a quiz, and I am looking for answers here. How well do you know this customer? Male 35, single, resides in New York, makes $100K per year. What do you predict this customer would do? the bank accidentally put 5,000 in the account. Would you give the money back, or would you take the money and run? I'm looking for an answer. A? So A is give money back. Why, sir?
That's what I would do. I'm 32.
So he'd say he'd give it back, so okay, well, that's good. And why would you give it back, though?
That's the right thing to do.
It's the right thing to do. All right, well, we found the one moral person in this room, I guess. Who would take the money and run? Sir, why? Oh, so you're pissed off on the bank charges. You figure you got it coming. Okay. Yeah. So yeah, you're moral. You're just like getting it back what you paid. So you all have an answer, right? There's an answer in your mind. But those of you who are more data science-y than developer-y, you're probably thinking I have insufficient information to answer that question, and you're right? There is insufficient information. But this is how we have to know our customers. Now, I'm going to give you a little more information about this individual, and then I want you to tell me what you think this person will do. You ready? This is George Costanza. What is George going to do? Take the money and run? Right. So those of you who don't know this individual, this is George Costanza. He's a character on Seinfeld. And anyone who's watched this show knew instantly when they saw him that he would take the money and run. They knew this instantly, right? Now, imagine if we knew our customers this well. This is sort of the goal, okay? This is the goal of creating these hyper-personalized relationships. And which is why AI is such an important topic, because the only way we can do this is to use techniques of artificial intelligence to process, analyze information, and scale our understanding of each and every one of our customers. Now, we did a survey on this last summer, and we said, hey, what do you think about AI? Right? And you can see here that they think, what are the biggest strategic growth benefits of AI in your organization? Improve customer experience. Okay, that's good because that kind of aligns with data and analytics professionals. It aligns with the business. Now, we also asked them, okay, what are you doing about AI? 58% said they're researching it, but only 19% said that they're training models. Okay? That's actually great for all of us in this room because it's a big opportunity. It's nascent, right? This is brand new. You've got an enormous amount of interest, but you've got nascent adoption, so that's good. And just like a few years ago, big data, MBA programs were holding big data classes. Now, Harvard University and Stanford all have AI on the syllabus in their business programs. So once the business people start saying AI, everyone else has to say AI and fall into line. And I love this guy because look at this guy's title at Daimler. Senior Machine Learning Engineer, Machine Learning and Predictive User Experience. This guy has the title that we were talking about at the beginning of this presentation, right? Predicting customer and putting it together to create new user experiences. Pretty cool. So the problem with AI is no one understands what the heck it is, or they have different views of what it is. So this is how I'm explaining it to enterprises, and especially business people. There's pure AI. And pure AI is the sci-fi stuff. It's Ex Machina, it's Star Trek, it's any sci-fi AI. And that really is the purest benchmark of AI. That would be pure AI. It mimics human intelligence, generalized learning, generalized problem solving. I tell enterprises, we're not there. That's not what you're supposed to do right now. But in 1967, Marvin Minsky, who was a co-founder of the MIT AI lab, he said in 1967, within a generation, the problem of creating artificial intelligence will be substantially solved. Wrong, totally wrong, but a nice vision. So this has created confusion at the time because this was this grandiose vision of sci-fi AI that we would create in the 80s. So what enterprises can do and what you can do for them is what we call pragmatic AI. And pragmatic AI can be used to create a modicum, a little bit of intelligence in our applications, intelligence about customer characteristics and their behaviors. So the net is pure AI, nope. Pragmatic AI, yes. And there's two ways to do it. It's the do-it-yourselfers. That's what we are here. We're going to build models and build AI into our applications. But ISVs are also using AI to build in. So the way to think about pragmatic AI, and the way we think about it, is that it consists of building blocks. And what we've done is we've identified these technical building blocks and what we call use case building blocks, and we've categorized them as pragmatic 1, pragmatic 2, and pragmatic 3. And the idea is that if they fall into any of these pragmatic categories, they're good to go. Companies are using it, you can use them, and you can combine them. Now, I'm showing you here the research side of it, and I'm saying cognition, because there's a lot of talk about cognitive computing. Cognitive computing, to me, equals pragmatic AI. So pragmatic AI equals cognitive computing equals pragmatic AI. So I want to talk to you about some of the technologies here, and specifically starting with machine learning, because all of you are probably using or familiar with machine learning. And this is used by a data scientist to train those probabilistic predictive models, those predictive models to predict what George Costanza would do, to scale customer behavior, to scale predicting customer characteristics. So a recommendation engine is a probabilistic model built with statistical and machine learning methods and maybe even some other analytical methods. But under our definition of pragmatic AI, that would be AI. So a recommendation engine, product recommendation engine, would categorize as AI because it uses one of the building blocks of AI. Financial services firms similarly use predictive models or AI models to create actions, suggested actions on client portfolio. And this is kind of a cool one. This is a small company in Austin, Texas called Interactive Tell. And what they do is they use Google's voice to text, real-time voice to text. And a typical large auto dealership, does anyone know who this is? Well, all the local people are probably not. This is Ernie Bach. It's a big, it's a big car dealership here. But there's typically 200,000 minutes of conversations per month. They translate the voice to text, and then they immediately do analytics on that, text analytics, to determine if there's a selling opportunity to this customer or if there's a customer service, and they alert managers and other people in the organization. So this company here is using AI that's accessible through the Google API combined with their own AI models to create a product. This company has fewer than 10 people, I believe. So pretty cool. Now, back to applications, because we're all talking about data analytics and analysis, but really what we should be talking about, what the preponderance of the conversation should be, is about applications and how we can infuse our applications with intelligence. So if you look at this diagram here, and you look at the app logic box, right? A typical application, you define the requirements, and then developers create what I'm calling here program logic. That's the code that meets the requirements. What most application designers don't do and developers do is they don't have what I'm calling here learned logic, right? And learned logic is logic that morphs, that adapts, and enhances the program logic to make the application smarter over time. So in order to do that, you need a machine learning regime to build those models and to build that learned logic, right? And of course, we're going to do that in Spark. The other key technology for AI is deep learning, and it's been magnificent, some of the breakthroughs that have occurred, and I think you've heard those from some other speakers. And as the CEO of NVIDIA says, it requires, he says, stupidly powerful compute processing. And I talked to a researcher in deep learning, and they said, hey, I have 20,000 tweets, and I want to do sentiment analysis on those tweets. Using traditional NLP methods, that took 5 minutes. 20,000 records, what's the big deal, right? They said to use a deep learning approach on this, that same analysis of those 20,000 records took 9 hours with the GPU system. whoa, why? Why would you do that? Well, the why, to understand the why, you have to understand, it's beyond the scope of my conversation to sort of understand the why. But there's another why, like why would you do that? And it's all about accuracy. So all models are probabilistic. The more accuracy you have, the better it is. And you might notice using Siri, Google Now, or Amazon Echo, accuracy has gotten much better. It's still not perfect, it's still not great, but it's getting better and better, and that's because of deep learning. There's plenty of frameworks out there. They're fairly technical now. There's many vendors working on abstracting these. So one of the best things to add to your resume these days is deep learning. But you better not just add that. You better know that deep learning isn't one technique. There's convolutional networks, there's recurrent neural networks, and you might have to know one of these frameworks as well. Very hot. But it does have limitations. And there's tons of opportunity, because many of you are probably thinking, oh, well, yeah, the Google APIs. So this is the Google API. I pop this picture in there, and you can see 93% chance it's a motorcycle, 88% chance it's a car. Really? I don't see a car there. We are in Boston. This is the Lexington and Concord reenactment. Pretty good. Person, people, militia, not bad, right? But here's a plane crash, okay? 80% chance that this is wind sports, okay? So the Google APIs, the Amazon recognition API, they have their limits, okay? But you have a huge opportunity. Think of all the insurance companies. Think of the years and years of photos that they have of steel roofs that caved in, of fenders that are bumped, and then think of all the labeling data, the structured and unstructured data that they have that describes those photos. That's not the type of model that Google's training, or Amazon, or Microsoft. This is the type of model you can train, right? Working with an insurance company can do it, or startup, whatever, right? But imagine consumers taking a picture, right, and then it doing an estimate of the damage, a bill of materials, and just everything else that a normal adjuster might do. Amazing. Now apply this to other industries like medicine, et cetera, you get the point. So don't think that the big guys have like deep learning and image locked up. There's so many applications like this for opportunities. Now there's a couple of problems with all this, with using machine learning and deep learning to build AI applications. One of them is these models that we've been talking about. And the problem is that it's not just one model. We wanted to predict what George Costanza did if he had 5,000. But think of all the other potential things that we might want to predict about our customers. It keeps multiplying. And machine learning models are very narrow. They're not generalized, they're very narrow. So we're going to need many models. And we can have one model that applies to many people, or we can have many models that apply to individuals. And it depends upon the data sets. I know, I'm sort of overstating it. But the point is, if you start to think about it, we're going to live in a world where to create intelligent systems, we're going to need a lot more models. That means a lot more scale. So if you do some math on this, we've got 10 characteristics. Say we wanted to predict 10 characteristics per customer, 10 behaviors, and 10 of their needs. All right, so let's just say that's 30 AI models. Say we have 1 million customers. Okay, many companies have 25 million customers. That means we need 30 million AI models. And I know you're thinking, okay, one model can apply to a segment. I get it, right? But actually, if you think about what's happening at Google and Ad, the segmentation of the models are lower. But there is a scale that's necessary. So we're going to need a ton of compute. We're certainly going to need cluster computing to prepare this data and to continuously train these models, many, many, many more models. Now the second problem is the data problem. Models just don't materialize. The accuracy, the predictive nature of those models depends upon the data. And the other problem is that all data originates in real time. It always originates in real time. Think about it. If you open your mobile phone and you press a button, you just created data that originated in real time. But we don't think about that. We say, oh, I don't have real time. Yes, you all have real time because all data is created in real time. The problem is that analytics, traditional analytics, is done much, much later. So we absolutely need streaming to feed our applications and to continuously refresh these models. Again, lots of compute power. So millions of models updated continuously in real time, and a great data pipeline is a prerequisite to pragmatic AI. So you can use AI to build pragmatic applications, but you have to have that data prerequisite. And I think that's why we're all so excited about Spark, because it's designed for speed. We need the speed to build those models faster. It's designed for scale. Right now, you're building 1 or 2 models. But I'm telling you, you're going to be building dozens, hundreds, and thousands of models simultaneously, so you're going to need a monster cluster. It was designed to do machine learning with MLlib right out of the box. Beautiful, right? And the Spark community has adapted very quickly to what's next with the tensor frames, right? I think the name was escaping, but tensor frames, so they use TensorFlow for deep learning and to support GPUs in a cluster. Wow, okay, great. We've got everything we need there. It also has this vibrant ecosystem, right? So there's lots of tools that can abstract a lot of these tasks so that you can focus on what's most important. So with Spark, you can build applications and use pragmatic AI to make your applications converse with customers in natural language, to predict everything about customers, to see with deep learning and image and video analysis, to discover new patterns, and why not hook it up to a robot or the IoT world to make it move. So when you are creating models, I don't want you to think of yourself as data analysts and data scientists. I want you to think of yourself as the next generation of application developers who are building intelligence into these models. So the opportunity for you is to use Spark, learn deep learning, learn machine learning, and think about, when you're building those models, how you can create that next generation of applications. To do your job, to do it well with Apache Spark. Thank you.